Good afternoon, welcome back. We will now move on to the parallel panel discussions on the two themes. In this seminar hall, we will have the panel discussion of theme 1, which is additive manufacturing for defense applications. In the auditorium right now, the second theme discussions are going on for defense manufacturing technologies. Here for theme 1, the coordinator is Dr. G. Madhusudhan Reddy, former outstanding scientist and director DMRL Hyderabad. I request the coordinator, Dr. Madhusudhan Reddy, to kindly come to the dais and take over the panel discussion session.
So, very good afternoon to you all. So, we have now reached the highly anticipated segment of our conclave, that is panel discussion, under theme 1, that is additive manufacturing for defense applications. We are indeed fortunate to have with us eminent technologists who have excelled in this field. Now I am privileged to invite to the dais Professor Satyam Subhas, IIC Bangalore, Dr. Balamuli Krishnan, Director DMRL, Dr. Naga Hanmaya, Director CMTI Bangalore, Sri ABVS Prasad, CE Semilab Bangalore. Please come and rise. I'm sure everyone is looking forward to an enriching experience through the ensuing deliberations in these panel discussions. To start, I'll pose a few key concerns for our experts to address. I request the experts to share their wisdom and throw light on the issues highlighted as we go along. I also request active participation by audience towards the end of this discussion, when the session is thrown open for discussion. In fact, I discussed with many participants, and they have given a lot of their concerns and issues. In fact, I listed down a couple of things. Maybe one or two I will ask the panel to discuss in that. The very first one is we are looking at powder actually. A very good feedstock powder is required. In fact, that is a key for metal additive manufacturing. Not all the powders are suitable for 3D printing. Yes. Currently, for most of the printing machines in India, the feed powders are almost fully imported and available only for selected grades of powders. What are the steps needed to produce powders? In fact, a number of talks went on that, but we are looking for the methods, and we are looking for cost-effective methods. Any suggestions in that directions we can able to discuss at this point in time. So, anyone can able to take it.
This is, thank you, Dr. Reddy. So this is definitely a very important point, quality of powders. And this requires a larger level of production of powder, large scale production, because the requirements will increase. From coupons now it's going to components, so powder has to increase, and there has to be a consistent supply of the powders, because in my personal experience we have seen that same grade of powder, if we buy from two different sources, then the chemistry varies quite a lot, and then because it's generally produced by atomization process, and then atomization process has many other variables, and then in that case it leads to deviation from exact composition. So compositional issues, and then the kind of atmosphere in which they are produced, like purity and then some kind of gas entrapment. Because for titanium powders it's very important, because the moment little bit of more oxygen is there, the entire property of the component goes bad. So this has to be standardized, but again the solution has to be sought out. Who will produce this powder? So that how can we identify a single source? So there is another way of thinking, that is this powder limitation and actual limitation can be overcome by this. So when I was talking to Professor Murugayan from IIT Madras, he said that it's motional barrier. So people have set it up that because of the closest powder bed packing, and then also because of the nozzle size, flowability. But what he said, that he had printed a blast furnace dust also to a shape. So this has to be either the machines have to modify. I think the best solution for size and shape is machines have to modify themselves to accommodate larger scatter in powder sizes and shapes. So this is one. And of course, parallelly, because of some very niche applications, we need sources for regular production of powders, like the VSSC can develop a vendor for their own requirements. And since it's a very specialized area, the same principle cannot be applied to all. So I think there should be many industries coming up in consultation with the users, and then they should produce powder. So that standardization, as well as machine capability, I am very much emphatic on that. Machine capability has to increase. I just wanted to add to it, this is just an extension to this. A couple of years back, when I was talking to some senior person in Fraunhofer Institute, they said that if we are going to larger sizes, we have to go for wires. Powder bed fusion is not the solution. So I think there were very few talks on wire additive manufacturing. This itself is a science, quite deep science. I think this also has to be looked upon. Okay, this is what I have to say.
I agree that because we are not.
Madhusudhan, I have a request.
Yeah, please.
Please tell all the panelists to be extremely brief,
Yeah.
and allow the audience to participate as much as possible.
That's what I already announced, because I'm open. And this last talk, because Chandrasekhan has indicated that there is no difference that.
Will you allow me to respond 1 minute to what Satyam said?
Yeah.
And otherwise, you want me to wait till to close the circuit and come back? On the
I
power.
wanted to close the biggest circuit, then I'll keep it open, sir, so that. So the last lecture, because Chandrasekhan has indicated that there is no reference data for process structure and property performance correlations. So what steps are needed to address this issue? How to overcome that? Reference data is not available right now. So what are the ways to steps needed to overcome this kind of things? So if you can able to say one.
Yeah, 2-3 options are available. One option could be assimilate all the data which has been generated on the test coupons and apply retrieval augmented learning algorithms and build open architecture systems which have got a lot of sensors embedded into that, keep generating the real-time data. So when you synergistically combine real-time data plus historical data which has been produced on the system along with the test coupon data, at least you will have a confidence that the population on which you are basing your decision is reasonably matched. So that could be one. And if it is done under the aegis of a national body like Semilac, it will have sense of the path and decisions.
So there is one more issue, because many have discussing with many people. Okay? They were asking that how to implement real-time monitoring of in-process effects during additive manufacturing to ensure their limitations. In fact, one, I think Professor Murugayan has indicated that so by changing the beam size, we can be able to overcome certain defects. But how to in process we are able to detect and then we can able to go further. That is a major limitation right now, widespread use of additive manufacturing for various business applications.
Yeah, actually, major challenge is since the machines are built elsewhere. Okay, there are a lot of models have been developed, innovative models have been run, the sensor integration, all have been demonstrated in several academic schools, including UV, CMTI, converted conventional FEM machine into a smart IoT enabled lab. The major issue is, as yesterday also mentioned by two of the speakers in our section, still controllers are not built in India. Built, say for example, I have a machine, DRDL machine, which was purchased from Palm. The software was built in India by TCS Group, but commercially TCS Group is not able to supply. That group itself is not existing. So naturally, if you have a data, everything is done, but fusioning into the machine control, so unless you develop the controls as a complete system, it is a major challenge. I think that is one limitation because the models have done, but it's not being utilized and integrated with the machine. So I'm sure the coming days, for example, yesterday Dr. Viswas was saying, so their controllers is customized and developed themselves. Now we are building 4 machines of AM of different, starting from food to food and to medical nutrition. So we are building our own controllers. So definitely these machines can easily integrate all these algorithms, particularly the process monitoring. So for example, DED machine which I am building, we are also going to integrate our food model which we developed our own scientists. I think that is easy, but definitely the bottom item machines will always have. In fact, back to the material is also same limitations. There are a lot of monopoly for the process and the machines built elsewhere. Academic school cannot take that risk of using any material at a time because their warranty period will not be warranty class, will not allow them to use any material. In fact, as a PhD student, I wanted to use for specific die steel on DMRL machine which is installed in CMTI as a customer. That was not allowed because that time DMRL has only 2 materials. So that limitation is there. I'm sure this problem is solved when we started. No matter this did not be a complete machine, even if you build an experimental setup as a machine, it's here. So a lot of is there. This is our time, we can play around with it.
So another query is how can we evaluate scientific methodologies to determine the optimal process for a specific alloy composition, model morphology, machine specifications, component geometry size, thereby you can able to minimize the laborious trial and error approach. Because most of the time, okay, we are optimizing the process parameters. It is a scientific methodology to minimize the trial and error approach for better property evaluations.
Yeah, so this is just an extension of what we normally do within metallurgy of being doing process structure property correlations, which is what we do. But certainly it has to move out from the trial and error to a more directed and Dr. Chandrasekhar already talked about the augmented learning part, the RAG thing, what he said. It applies in a broader sense across the board also. So the idea is to have a standard framework for how we are going to talk, in some sense, an ontology of the data that is going to be associated with additive manufacturing. I think that is one. And fortunately, the build equipment comes with a lot of sensors themselves. So in terms of the process parameters, people will come with the experiment, right? So that has to be integrated with the material characteristics, the powder characteristics in terms of the particle size distributions, what are the other characteristics that it has, its flowability and all that stuff. And then naturally we'll have to put in this large language model or something like AML. So it truly, well and truly will be a multidisciplinary field with different people working together and closely. It is not like passing of data from one to other, but working as one integrated unit and then having some kind of mindset. The first thing is to get or agree upon our data structure, the framework for the data structure. Second is to integrate that for what is the material to the process and the kind of product. And incidentally, the mechanical civil people probably have a much better way of looking at quantifying the topological complexities and the challenges that go with it. So I think the material, the structural, and the computer science AI data aspects have to be integrated together. I think that will be one way to speed up all this process.
Thank you. So there is one good query on qualification certification, because right now it's in the laborious and time consuming. So for broader application of additive manufacturing process, how to accelerate these steps? That's what in the last lecture also the speaker has mentioned several times. So what are the methods we can adopt so that we can minimize certification time and for broader application of this technology?
My comments are specific to aerospace defense applications. Most of our designers, we tend to overlook the design for testability and design for life when we make aerospace product. So mainly design for life is like space application, like rocket, it is a one shot. But for air launch missile, it is not one shot, but it is somewhere in between an aircraft and a one shot, because the air launch missile is integrated to the aircraft multiple times, it takes off on lines. The impact load, shock, accelerations have to be, some accelerated test to be done. In the case of additive manufacturing, we have a lot of highlights of excellence, the data is there. But the biggest complaint for the certification agency to address is, if they have to make 20 parts, the amount of parts they have to make for the accelerated testing and lifing analysis is order of magnitude more than that. And the time and funding required for this is difficult for the small entrepreneurs. So what I suggest, and we are taking some baby steps in this direction, we are planning a national data analytics center at Semilac to archive all this data. But the concern for all the R&D engineers and academicians is the lack of a stringent IP legal framework in the country. So we have formed a national committee to evolve that legal framework, wherein we want to ensure the owner of the data that they can share the data with us. The end customer, whoever wants to come, we want to be a facilitator. We want to give 2 digital keys to both of them. It's like your bank locker. Without your key, no one can access your data. So the fear of unknown is not ensuring seamless access to this data. And we are planning to impinge by data analytic tools. We keep talking about AI, ML and all. So we need high-end data analytic tools with a good computation. So with all this, we are planning something called certification by analysis. Because the hard way of experimental validation for a country like us, for a sunrise technology for AM, it is very difficult in terms of time and funding. But certification analysis, we have 2-3 important enabling factors. The first one is very good models, high fidelity integrating models, very good modeling simulation analysis tools. And we need trends from the existing data, evolved from the data and tools, so that the sample size is very big and the bias and color from the sample size, big sample size will be eliminated. So these are some of the steps we are trying, and the most important is we are allowing tailoring of standards. A lot of people are talking about standards. As a designer, I feel for a sunrise industry like AM, please don't tie yourselves in bounds with standards. We should allow tailoring of standards based on specific application to the product. Even MIL standards, if you see, they have broad guidelines documents. We need not necessarily follow. Like Israelis, they are big champions of tailoring of standards. If we blindly follow standards, it will be difficult for us to be, you can't expect an infant to run a marathon. So you can't expect to impinge stringent the military standards on a infant who is trying to do. So we are allowing tailoring of standards, and we allow staircase approach of certification. So we give them limited life, limited applications, non-primary load bearing structures. And once the enough knowledge base and database is built, then we can go forward. Yes, I hope I addressed your question.
Thank you. There's one user has requested me to pose this question. Okay? There are certain unresolved challenges and constraints exist in the post-processing of internal features of additive manufacturing products. What future approaches could be adopted to reliably overcome these issues? Because there are fine channels and length of the component is very big, and internal features there are channels. Okay, how to ensure that they are able to get a smooth part? Because that is a major bottleneck right now when you are looking for internal cooling channels for a bigger components. Because this question was posed from DRDL, okay, so they were looking for an answer for that. Anyone can answer for that.
Probably I tell our experience. When I was talking about PS4 engine, when we made fuel goes through the channels, and channels are helical. One of the biggest problem is the debris presence, and here only the metallurgist comes into picture. The first step after additive manufacturing is the stress relieving operation. For 316L, the material that we used for printing, if you are using a high temperature, 316L can be, it is stress relieved at 650 degrees Celsius, and it can be any at 1040 degrees Celsius, any stainless steel. Now, if we directly do 1040, whatever powders are sticking inside, they will just get sintered, it will never come out. So what we have adopted in our approach is go for low temperature stress relieving annealing, go for CT, and the advantage is in case the debris have not come out and blocking the channels and roughness is high, you can go for a high pressure pneumatic cleaning and come back to CT again. Because ultimately the idea is that your channels or flow path should be very clear. So if you sinter it, you can never remove it, and the hardware has to be rejected. So whenever somebody is looking for flow path, that smoothness or that debris or anything, no, don't go for high temperature. Say don't sinter the powder. Don't sinter the, so that is the trick. And of course, second thing is abrasive flow machining. But people who want to do abrasive flow machining for internal cavities to improve the surface finish, if at all if it is required, they have to be very cautious because it will not remove uniformly. Sometimes the material used for material itself can be clogged, because if it is a straight channel, it is okay. If it is a curved channel, it may not come out sometimes. So these are all very tricky things which can be learned by experience.
Thank you.
Thank you.
So now the session is open for discussion, sir.
At least the first point.
Regarding powder, that's one of the biggest bottlenecks. Now, you can't expect 5,000 alloys to be available and in atomized condition. I think ARCI created a facility, I don't know if Vijay is around now, where anyone can go with a few kgs of a block or stock. They have an arc melting unit. Under arc they can melt and atomize. Now, when you talk of atomization, there are two possibilities. You can do gas or water. Water will never give you the same quality as gas, but gas is expensive. So it should be left to the person concerned. Now, see, in India we have to understand that facilities exist, the topmost comparable to the best in the world, more or less they exist in the country. The problem is in the denominator, how many users, and then next question is where is it and accessibility. So the government has to allow every laboratory to throw some of its existing facilities to the public. For example, if DMRL has a facility and somebody from a university or college wants to come and make use of that, one has to go through a huge amount of permission and other approval processes. We have to make this very, very simple. See, similarly in CSR laboratories, a lot of facilities exist and you can't charge. Now, you cannot run a facility only to do charity. You also have to recover the running cost and the future replacement cost. So you have to come up with some model. And we from INE can actually look into it, and then for every challenge that Madhusudhan is posing, we will try to pick the brain of the entire audience here. Whatever good suggestions come, we will see whether we can create a policy document from INE and move ahead. So this is wire feeding is something which again it doesn't exist anywhere in the world. Now, like I said, arc melting, gas atomization. It may be worth for one of the labs to explore a possibility. Someone comes with powder, can we extrude and create a wire? Okay, and if we can create that wire, so here is an opportunity that we can be the leader in the world. Nobody has so far talked about it. So if we can create such a facility, and then that can be. It depends on whether the weldable powder or not and fusible or not. But worth trying. I think I'll stop here. Others.
So just respond to one. Just so that people are aware, just in response to one of the points about opening of test facilities, I think it's already started, sir. In fact, earlier our practice was, if you were a few samples for academia, we are doing courtesy, like you said, it was free of course, and because otherwise both from our side and that side we did or rather used to did the process. But of late, in fact, especially the last 8 to 12 months, considering that these have been made accessible to industries and small industries, especially MSMEs and startups. So the consultancy policy was getting revised. In fact, we had done a few very specific cases in the last 4 to 5 months. Rather 4 or 5 cases in the last 8 months. And I think just maybe next week or the week after this, DRDL's policy will get released. The new policy is getting released. So in terms of giving access, and like what you said, so that is already taken care of. At least only the basic operational cost will be factored in. And we are not going to amortize the cost of the capital infrastructure because we know that that's going to be too much, especially for academic institutions. And as it is in the research projects that are being funded by DRDO, whether through research boards or through the COEs that have been set up, now that specific segment is there, which resources you need from the lab. And as long as the utilities, the facilities are available and not already overloaded, it is being offered at operational cost without anything. So that policy is already there and we are starting to implement it. But that was a gap earlier. I think that is being addressed for sure.
Yeah, hello sir. Sir, I am from Bharat Electronics. And sir, in our company, one metal 3D printing is there from 2017. But our people are not effectively utilizing it because of many reasons. So one of the reasons what we feel is this 3D printing takes place in a closed chamber which requires nitrogen gas or argon gas, and those gas also required some chimneys to taken care, and also powder is like some health hazard. So if we have to go near the powder, we have to go with safety gears and all. So people are hesitant to use powder as frequently as other processes. So can we develop something other than powder for additive manufacturing?
Why not is anyways there? Why not additive manufacturing? Okay, because those powder with wire also they are able to build layer by layer your component. It all depends on the component size and other things. I'm talking about metallic one.
Sir, you are not audible.
No, other than powder, okay, there is another manufacturing process, wire arc additive manufacturing process. That we are not covered in this particular symposium, okay, in this conclave. But with wire we are able to make for mixed structures, basically mixed structures. So, but the surface finish is not that good. We have to look for again some of the machining operations are required. So, what kind of components you are looking and what kind of material you are looking for that?
So most of our materials are like aluminum based. But compared to like metal additive manufacturing, plastic or polymer additive manufacturing has developed more. So their SLA process, we are finding very good quality products. So similar to kind of SLA, can we have in metal also? Like something metal resin kind of thing can be made, which can crystallize as per desired shape. And we can get.
I just tell you, see, first of all, the use of powder is not as hazardous as you are thinking, because all over the world people are using. Of course, the precaution has to be taken care. One has to really put proper precaution. So that is one. Second thing is the whole process of melting and solidification as it happens in the case of additive manufacturing, that is quite testified, so that you don't have to worry about it. Gases are definitely needed. Gases are definitely needed for usage of that. But gas is also nitrogen or argon, whatever you are telling. It's an expensive process, but that can be maintained, and you don't need. You definitely need a duct to for gas testing, but it does not require any special thing. You can. Since you are living in BEL, you can always visit the nearest institute like IAC and Bharat Electronics. No?
Yeah, it is near to our place.
Right. So
you from Bangalore.
Right. So you could come and see how we are having the machine. So I don't think this is a big problem. You can use it. I think you are lucky that you have a good machine and you can use it. It's possible and it is being used all over the world. So there is no problem.
Yeah, so maybe sir, because of these reasons, it is not being used so frequently as other processes.
But let's explain the difference between polymer annealing and metal joint.
Right, so what probably one of the issues was why metal has not picked up so much as polymers, because the temperature levels are very low in the case of polymers. So the simple systems can be used and the structures can be built. While for metals you need a laser or electron beam source. Temperatures are high and then metals are also prone to oxidation, right? So therefore you have to have, as you have already mentioned, you need to have cover gas. So making component out of metals is, by virtue of the nature of material, it is slightly more cumbersome than making with polymers. So that's why, that's the reason.
Okay, then can you be allowed to respond because I think these are someone slightly different answer. Are you asking what is possible with that polymerization? Why can't this be done with metals?
Yes, sir, that was also one of the questions. Like,
So a quick answer to that, you have to understand what is possible with polymers cannot be possible with metals because the bonding characteristics are different. In polymerization, you are talking about building a chain. In case of metal, you are talking about either fusion joining or sintering. So the very processes are very different. You can't expect the same thing to be replicated in case of metals, what's possible. But what Satyam said is very correct, that the whole world is using powders either through powder bed approach or powder feeding approach. And if it's a powder bed approach, there is hardly any health hazard issue. In powder feeding system, there could be, but there are ample measures to protect yourselves. So all these are standard practices. You go and talk to, you're in Bangalore, right?
yes, sir.
Go and talk to Satyam or somebody who is in the job and then discuss with them. In ISC, in ISC.
Yeah, so this is Ajay Kumar from IIT Tirupati. So after listening to the lectures since yesterday, so we have seen that the data and properties for the different additive manufacturing processes, a lot of research is being happened, and so we have seen that the data is very scattered, one process to another process. So I was just thinking, can we come up with to form a cluster between the academia and the R&D labs and industries, and each cluster can focus on maybe one set of process or one set of properties, and so that will help to minimize this scattering as well as also to come up with a certification and policies. That is just my idea to propose here. Thank you.
Thanks Ajay. I think this was the proposition of Professor Manna, who wanted to make a group at least with regard to the database and data handling in terms of ICME approach, alloy development. So this is being done, but as far as aligning institutions along certain verticals is concerned, sometimes it is very difficult because many institutions would like to try more than one method because that is more convenient for them. But definitely, what I feel is at this stage, it's important to have a database that who has what capability. And similarly, extending my thought on the previous question of powders, actually there is no database available about that type of powders, nature of powders available in the country. So this is very important, the capability of powders. Powder manufacturing or the type of powders, it should be somewhere documented. I can tell you my experience, I think 3-4 days back, a very senior scientist, retired, my former colleague from DRDL, who is now heading one of these DIA centers, he asked me about where can you get this powder. So senior people are also who are in the job for a long time, they don't know about which powder to get from where if you have not to import. We know lots of sources where we can import it from, but in country, who is making and all that and what kind of powders they can make. That database is required very much.
Okay, thank you.
No, moreover, sorry, just add that. See, if you look at AM right now, all processes have been developed parallelly. The maturity level is limited. If you ask me, I am there in this 20 years in this domain. You give me a component and can you build in X process, Y process? So then I will ask you back only if yes. I think that is the kind of status this is getting award. But at the same time, yes, we built DED machine in 2015 by integrating a system, leveraging what we integrated. But we reached to the confidence to the level we could able to build a machine 99% from Indian content. So you will be surprised, maybe you will have a DED machine less than a crore very soon. I think that is what is there. But the document, what is that's the limitation given. I think I am chairing one of machine tool sectoral section committee, VIS. This proposal was there that we generate some standards on specifically for additive machine building. But right now the technology is not matured enough to build that because several subsystems, aggregates which are required to build the systems are being sourced elsewhere. But yes, this is definitely is required. But question is instead of dividing on the verticals, so better what we can do is a forum is created. That forum data could be shared. Maybe it will get evolved. Some definitely regulatory agency or certifying accreditation agency could be able to take up this and come up with the standards which are particularly meets the industry's demand. I think that would be the ideal approach.
Just to add one sentence to that, exactly what you said was, that I might go the other way to get to this quickly. So we might have, rather than focusing, we might have to do round-robin based studies, where the same powder is being studied by 3-4 different groups, and then all the data gets put together in one standard framework and format. And so that that data can be fed back to the powder manufacturers also, so that the consistency and quality of powders also improves. So it's very, I think whenever we get scattered, I think it's a very important point that you made, but and this is applicable in general. Whenever there's a scatter, there's a tendency to go to only one person. I think usually that's an emergency based approach. See, normally, many times I see also as director in the last 18 odd months, we see this as a general approach. Typically, you take it from me that, I mean, this from my personal experience, it's only a quick fix approach. It will solve your problem today. But in the longer run, it's making the problem bigger. Right? So, because maybe your equipment will give you one kind of result. So that is, I mean, this difference between accuracy and precision, I think people know. So the moment you get scattered, I think it's very important that you pass the sample along, pass the test along to 4 or 5 different people who have calibrated their equipment, who have calibrated everything, and then compare results. Otherwise, you may be going chasing a false positive or a false negative and drawing very dangerous and wrong conclusions based on that.
I have just 2 specific comments. One thing is it's very nice to hear the range of presentations really discussing wide variety of problems, their experience and all that. In 1 or 2 presentations it was also told that I think there is a need to create some kind of forum, common forum, where we can bring government agencies, private agencies, industries and all that. Because as we see that the work is really moving from conventional to the additive and then it's going to grow, that's what I understood. I think that could be one of the recommendations if it is not done already. I think you have to create a forum and then create an opportunity for people to come and discuss on a periodic basis. Then I think many of the issues what we are discussing, it should not happen one time and leave it there. I think that's what IND generally does and we should really take that step. That's number 1. Number 2 is in one of the presentations I saw a fairly wide numbers of software displayed, and he also said that it's all imported. I think high time we being the IT capital and having these very strong base for software development, if not all, at least some of them, I think we should make an attempt and try to indigenize. I think unless we do that, we are not going to go anywhere. These are 2 very specific comments.
Just to add some of forums, somehow we have not succeeded in this domain. I think I'm sure Chandrasekhar also aware of this.
How will you succeed?
Yeah, I think, no, RPSI was formed, Rapid Prototyping Society of India, that has been closed. Now, Additive Manufacturing Society of India is still functioning, but it is limited to only organizing events once in a year, that way. In addition to that, there are two more forums, 3D Graphy, which is centered around Mumbai area. They are also organizing a range of events for medical, engineering, and also some of design for AM. In fact, next event is in November. IT Delhi is a big program is there. I think there are 4 entities right now, 4 forums are working, but it is driven by 1 or 2 people. I think maybe if you can bring together this ANAE or some, I think that is possible.
Maybe we not getting,
Yeah.
person can move together, create one, like a single nodal agency. I'm sure everything has, they can work like that, and then as possible go and create. You know, what I see is that DRDO has one kind of work that is being done. All laboratories are involved in one way or another. I think DRDO should take the lead, and that's the joint hands.
Yeah, and to the previous one, the powders which you were talking. So there are Indian firms who can do the manufacturing, and one of the iron 718 powder, which has been indigenized by Indo-MIM and which was been certified by Semilac for the additive manufacturing. This is one of the things. I think they can manufacture other powders also, stainless steel, 316 and other things. So that also can be looked into. And another thing which just now it was being mentioned is the database, basically the material allowance and all for this particular thing to start with the powder-based additive manufacturing, ZDBL and all. So that needs to be generated, maybe for not all materials what alive, but what are the important ones which we are using at present. So to start with that, we should have that forum also, maybe a common forum to start with, because it requires some funds and all to do that, and that can be used as a allowable sort. Then we can use as a, then when we are making components and all those things, the factors which can be used for that. So these are the things we should do it as a forum. Forum it is possible, but not as an individual. I think everybody's point of view is that. So that is, and one of the other things for the standards which we are talking about. There is a, I think, with our C's chairmanship, there is the AOSCC committee is there, and there is the additive manufacturing working group is there. So there we have a participation from the industries, DRDO and other people also. So there are standards we are making. Recently started that one standard on IN 718 has been made and which is being submitted to the DSC cell. And similarly, the from the other whomsoever is here, they can suggest what are the standards needs to be made. They can be a member of that committee and can participate in making the standards. That is my suggestion.
This is quick response to the software development part. When it comes to polymer based additive technologies, I think there are a significant number of designable attempts, particularly with reference to fused deposition modeling or filament fabrication and DLP or VAT polymerization techniques, where software efforts have been there and they have been integrated into the hardware also. But when it comes to metal AM, the software development has not taken off in a very big way because of the fact that typically an agency which is into the development of a specific technology-oriented system will tend to get the industry-recognized de facto softwares from places like Belgium and Germany, wherein you are able to articulate the laser beams or electron beams with precision without much significant effort, and concentrate more on the hardware development. That is the reason why the software development in case of metal AM has not taken off the way it should have taken off. But one important point in the recent times, few startups have come up with reference to providing quick simulation results by taking care of the mechanistic models as well as heuristics connected with additive manufacturing, and these agencies are able to predict the problems that are associated or the defects that are likely to emanate once you take a powder and start treating with their specific energy source. This has been happening significantly in the last 2-3 years.
Hello. Hello, sir. Yeah. So this is regarding the powders. Actually, why can't we explore, like we are very good in, say, especially if you take two companies like MS and the Intech DMRL, that is a made in India kind of machines which we have been developing. Then in that case, why can't we have a kind of, even if you see matrix nano, there is a one Indian powder manufacturer which is there as a startup in a NCAM Hyderabad. So then why can't we, say, submit up all these people, and then even Civilac is also going to play a major role here. The standards, how the internationally, globally they are doing it, like ASTM or ISO. So then why can't we in India? Why? Because we are growing as far as machines are concerned, as far as powder manufacturing is also Indian powder manufacturer company startups are coming up. So then why can't we see in a global level, let's say, why can't we think in India? Like we have a better kind of thing, and softwares also, if you see, like Intech DMRL, they are doing a good software development in terms of simulation of metal powder bed systems. So then why can't we pull up in India? So then we definitely will come out with better results than elsewhere in the global level. Definitely we will put a mark. That is my opinion. Like we can even explore this idea, maybe like with forums like this or any other way which we can pull up all these things. Why? Because we are doing great in terms of machine building. In metal also, we are doing great. So powder manufacturing, why can't? Then why can't we pull up all these people? And then why can't we do that? That's my suggestion, sir.
But sir, can I respond not to this, but in general? Firstly, borrowing from what Dr. Suresh mentioned, and you see, the question in the country to a large extent is who will bell the cat? Everybody has an idea, and this is where I think we as a National Academy, we have a role to play, and we are willing to play that role. Naga, are you a member of the sectional committee? You are a member of the sectional committee, Satyam. The sectional committees were given a task to come up with 1 or 2 technology gap analysis forecasting areas. Why do we have to depend upon some of the forums that you mentioned, some of the organizations? They must be doing well, I'm not quite aware. But the reach that INE enjoys is much bigger than any of these small or big whatever organizations. So for example, if Section 3 decides that we need to create specifications, that we need to create certain standards. So all you need to do is to make that proposal and collect a team of volunteers who need not all be fellows. You can go beyond fellowship. A team of 4 or 5 persons. And then INE head office will create that discussion forum for a while. And then depending on the progress, we'll review and see whether we should now touch or connect with some ministry or some other DRDO or any other bigger organizations and see how we can do that. What Bala commented, I really like that round-robin concept. I will cite an example how international events actually take this. I used to work in a concept called nanofluid. Many of you also may be familiar with that. You probably are aware that one individual from MIT took an initiative, got a funding from NSF, and about, if not 100, easily close to 100 groups around the world. And I also was, from India, there were at least 3-4 groups. I was also part of that group. So the whole project was funded by NSF to do exactly this round-robin testing. That how does nanofluid really show you higher conductivity than water or any other fluid? To what extent and why? The why part came much later. And then, but ultimately what they did was, in my opinion, was not desirable at all. They went ahead and published a paper without taking consent from everybody. But here in India, if we say that we identify 3 or 4 shapes, a nozzle, a tube, or a fin, or something like that, I mean, we create some 4 or 5 target products, and we throw open a contest and say 10 different groups or 20 different groups, let them produce. But when they produce the final one after the optimization, that must be videographed. And we collect all the data. Temperature, feedstock, properties, shape size, and so on and so forth. That itself will give us at least something to report which hasn't been reported, tried so far. So that again is doable. So again the same question, who will bell the cat? So we will try to do something like that. About the powder, a company like IndoMIM or somebody, I was referring to ARCI, now I have better ideas. Why ARCI? Why not a company comes up with a proposal? And we'll discuss with that company and see how we can make it a national initiative. That instead of with one 10 kg powder, you know, academia, people from academia, including me, they're all very poor people. We have a project grant of 20 lakhs or 25 lakhs, and we want to deliver enormous amount of things which we cannot do. And so the amount of powder or amount of material with which we can approach a company would be hardly 5 kg. And that's on the higher side. So can a company, I'm just taking the name of IndoMIM because that's a very well-known company already. There could be some other companies, and why can't they think of creating such a facility that I have an art melter which can go anything from 500 grams to about a few kgs, and followed by a gas atomizer. Okay, how much does it cost per kg? And what is possible in 718 is not going to be possible with titanium or more reactive metal. So we have to also build that into. So that's and about software. There again, we actually can create a forum or a platform where we throw open maybe 2 groups or 5 groups from ISC, 2 from Bombay, 3 from some other institute. If they want to participate, and there are PhD scholars, one of my own scholars is working on that. We haven't made a huge progress, but some progress. So why can't we then create a platform and do that? So in all these, actually, I would very strongly recommend to the fellows that, we are less than 1,000 fellows in a country of 1.4 billion. Anybody who is a fellow of IME has an obligation to the nation. Each one can actually make a huge difference to the society. And IME is looking for such volunteers. So let's try and do that. Thank you.
With regard to quality of the powder, all the time discussion is going on, particularly the Ethanol 718. In the Indian scenario, industries have come up, they set up the organ atomization plants and all that. But today, we advertise, I need a Ethanol 718 or Ethanol 625 nickel-based superalloy for aeronautical application, less than 100 ppm of oxygen, with an average particle size anywhere 60 to 70. Honestly speaking, no industry is able to come forward to quote for that. The reason is, scale-up version, 20 kg, 15 kg is fine. When they go to 100 kilos, where this deficiency is technologically existing, is the reason is that fabrication. When I say that powder quality means, everybody jump onto the powder manufacturer only. But engineering aspects of organ atomization, they take care of the induction melting and cooling tower, 20 to 25 feet long cooling tower, the fabrication there, the welding and weld joints, integrity and leak rate, nobody bothers. Then afterwards they collect the powder at the bottom, that they will try to characterize and find out the oxygen, 2000 to 3000 ppm oxygen they report it. The size range of minus 150 to 400 mesh, that corresponds to 106 microns to 37 microns. That is the range for aeronautical as per the AS standard. if we deal with a proper ingot, vacuum induction melting, generally a reasonably or average vacuum, 10 power minus 2 to 10 power minus 3, the vacuum induction melted any nickel based like will have 30 to 40 ppm oxygen only. It cannot be more than that, provided your raw material is reasonably good quality. Now, if that is the thing, the size range is 106 to 37 microns. Generally, the oxygen becomes 3 to 4 times only. That means 120 to 140 and not more than 150 ppm. But where from the 2000, 3000 ppm oxygen is coming? The reason is we are not taking care of the vacuum levels or leak rate of the powder making system, atomizer system. This is one aspect. Next is there is a specification for aeronautical applications. What are the ceramic inclusion content? What is the size of the ceramic particle? And today, in the foreign countries like PSI, Boganas, HC-STAC, Crucible Research Center in the United States, and all that, when I quote for them, ask for this thing, they will honestly say that, sir, beyond 140 ppm we cannot supply. Below that we can. They have optimized these conditions. But now, today in the Indian scenario, we are talking about the 100 kg, 150 kg. What is the nozzle you are using? Zirconia nozzle. Zirconia nozzle 40-50 years ago it was there. That means you are mentally prepared to add the ceramic inclusions into the nickel-based superalloy powders. Now the new designs have come, ultra high temperature materials. They prepare the compositions they have not disclosed, but the such nozzles are used. The molten metal simply, at that pressure, 30 to 40 psi bar pressure, when the liquid metal is experienced, it does not almost come in contact with the nozzle. It just flows through that and disintegrates into molten material. That is the technology is going on. That's where the quality comes. So, then third important point is screening. Where are we screening? At least minimum of 100 class of clean room is must for this spherical pre-alloy powder of aeronautical standard, the size range I have mentioned. Generally, still we are digging to 10,000 class of clean room only. Screening, no powder production technique will give you correct size range. We have to screen it to appropriate size range. Then powder handling, storage, all these. So the 4 or 5 aspects, unless otherwise we have a strict control, as someone was telling, committees can be formed. So every aspect, committee 1, committee 2, committee 3 in the country, they should put the stringent conditions wherever the powders are produced for different applications. They should refer to the committee. Unless until the committee clears technically, we should not get into making a large quantities of powder. Otherwise, we will not be able to make quality powders. This is what my personal feeling based on my experience at DMRL. Thank you.
Thank you very much. Yes, sir.
Thank you. I just want to add one point only. That's to second Professor Indranil Manna's suggestion. As I see, the discussion is converging towards 2 or 3 points. One is the creation of a database. Second is the creation of standards which have to be followed. But there are individual cases, but I'm trying to sum up. And the third is the sharing of facilities and expertise. What better forum than INAE to do this? Whether a sectional committee in metallurgy or mechanical engineering will do, or whether the INAE on the whole will take up certain emerging technologies and create these forums. But INAE is the best organization to take that. Particularly, as you pointed out, the concentrations is great talent in INAE, FNEs which are in various fields which are the great experts. It's ideal that INAE takes up this task. Now identify from this discussion, which is easily possible. I just write 2 or 3 points. Database of various powders. Most that's fine, because that's where we are probably lacking the uniformity. So create uniformly available databases which companies are producing, what kind of standards they are following. But create standards also. So that for each one of them, as the gentleman suggested just now, create standards for biomolecular species. Super advice. Similarly for aluminum glass, soft titanium glass, and whatever. Create the required standards which have to be followed by everybody. And then the most important is that some people can afford, some people cannot afford. So share the facilities, which I think Bala has already pointed out that we can share. So similarly, other laboratories or other organizations are subject to, of course, the proprietary and patent limitations of various companies. Even companies can share, as long as they are not limited by the patent considerations. So, but this forum can only be created by INA. I cannot see any other organization doing this. So I second Professor Muna's suggestion, and also this meeting itself is organized by INA. So no better than that, and I would like to submit to this body that we ask the President of INA to immediately create this forum for, you may call it by anything, but for additive manufacturing, whether it's defense applications or whether it's commercial applications. Thank you.
Related to borders, as the DMRL and the ARCA, they are the R&D organizations. As somebody was telling, the matrix nano in Hyderabad, MIM. Actually, we visited Indo some time back, some 4 or 5 months back. We were asking some MDL group border can you make? We were asking what quantity, how much you want, because they don't have that, even titanic borders we were asking actually. So, because they were not thinking of market and all. Because DRDL, they have some funding system like a technology development fund. I think up to 50 crores we can give. So why don't we think towards that? So we can fund and they can make powders so that indigenously titanium powders or MDN group and other things we can work out in that area.
I think now the refractory materials and powders.
Maybe C103 also we can think because we were importing.
Yeah, so whatever you are talking about TDF, I think that letter was circulated to all directors, to all labs. And Dr. Joshi from here who also happens to be the convener of this conference. So Nomesh is still here, right? So we have a DRDO AIM roadmap which is being overseen by Secretary himself. So all this is being talked about there and TDF is happening. It's the unfortunate, I'm sorry to say this in the general audience, but as a director I can feel the pain, so that I'm sharing it. So Haribhushan sir, don't take it wrongly. When and Nomesh will second me, because I'm sitting on 2 committees looking at this from Delhi. When letters are circulated to labs, hardly 2-3 labs reply. Everybody, see, material means DMRL or DMSR, heat metallurgy means DMRL. In this forum we are telling, in DRDL, I asked Nomesh is the one who is collecting the data. We got 3 responses, 2 from DMRL, 1 from another lab. There are 41, I'm telling you, there are 41 DRDO labs. What we are doing, Additive Manufacturing, 7 international collaborations, we have been asking for input. Ask Nomesh, half page we are not able to fill. Why?
People are busy.
See, that's what. People say like WhatsApp site is wrong. This is beautiful, this is the positive peer pressure. When 10 people, when 80 people are sitting here and talking, we have people like Professor Manna, Professor Kudumbarao, Suresh sir, all of them telling, all of us get invigorated to tell. But on our own, if you see it on your computer, we don't have the to cross that activation energy to write 2 lines. I was sitting with the DIC and Nomesh is there and the DPNC, 2 DGs were sitting. Yes, Additive Manufacturing, so secretaries are convened a committee. All the research boards have all proposals within DRDO. This is for the benefit of people from academia who are sitting here. Because everybody wants to say, I will do additive manufacturing for aerospace grade Type 6-4. We are having 25 such proposals. Which one do I fund, which one do I not fund? And from the professor side, everything is valid. They are right. In fact, we keep talking this to Satyam also. The professor whose professor doesn't get funded feels rightfully rejected, disappointed. But how can you fund 25 proposals which talk about I will optimize parameters for LPBF for Type 6-4? So we have formed there's a DRDL national mission is there. Joshi is there, Ramesh is there. We have Sanjay Bharat from GTI, John is here somewhere. These are all core members of that committee. And when we seek input from other labs, the same 5 labs and the same 6 people are giving inputs.
You know, DRDL already, DMRL, GDL.
This is what I'm telling sir. DMRL cannot take care. Please understand. This is what I checked. You are saying DMRL is R&D lab for metallurgy. I want powder. That is not enough. We want commitment. See, Professor Pudura was just now telling, Dr. Suresh was saying also, no? Stakeholder commitment is a different thing. What Professor Ajay was saying. Wish list is different from a commitment. He also said, who will bell the cat?
One more thing, sir. Here, what I suggest, as that core captivity is going, who are the working people? Top level it is going, it will come to down the level, I do not know. So better to attack directly core. Suppose John or myself is there, they will come to us and we'll see, sir.
No, that's what I'm saying. See, but
sir, people who should identify, then only it will work.
See, you should also understand, Delhi cannot send to individual scientists. Delhi will send to director. In my lab, since I am director, I know. I give to my tech card and say circulate to all group heads and project directors.
Sometimes.
Okay, yeah. No, but what I'm saying is, sir, this is not specific. This was only one example. But in general, because I'm on long-term director research committees also, which problem should be given to academia? Because we have this much expertise, 15 centers of excellence we have created. I am a core committee member, that's Siddiqui sir was chairman, now we have to find another chairman. That committee also received only 4 responses from 41 DRDO labs.
Sir, one more point, sir, just another point, one small point, sir. This is surface finish. This is another important concept of this additive manufacturing, actually. So, particularly aerospace and defense, whether it be ISRO, I have talked to Surya and Murthy also. So, that particularly conformal cooling on this area. So, share these things. Particularly what I was thinking, maybe ISRO, LPS, DPSSC, DRDL, maybe RRCAT, I think they are also working in this area. So, we should see that finish improvement. No, we are trying to do something. We are not able to say.
Okay, just very quickly, sir. I think Sir wants to say something. But just to respond to this, I think it's fine. Sir, we should not know at senior levels, we should not, this is a scientific collaboration, right? I mean, unless he has a situation when he cannot share, people are going to share. See, we should not try to regulate everything, right? When we are saying overall database level, I mean, that is so-called Google's thing of federated data, and privacy and control was also discussed, right? So, we cannot try and regulate, you should share your data. If there are 2 groups which are working, they will be happy to share unless there is no reason not to share. So, to answer your original question, therefore, all the requests can be given, or you can give to John. John will happily coordinate that. Incidentally, all those 3 are included. C103 and other 2 errors are included.
I will coordinate other people at the thesis that I will give input is given.
Yeah, that is.
This is the formally with nuclear complex. I think there was one topic which I not discussed much now, but it was mentioned. Is it possible to have real-time identification of defects? Right, I think that discussion was not there. I would like to throw a few points here. If I remember correctly, yesterday one paper was there on this aspect, but it did not elaborate in detail. It hinted. But I would like to tell that these techniques are available. What they are called is real-time micro-reticle. Real-time, as the process is going on, it can identify, mostly these are adopted in the welding industry. The sophisticated welding industry. Generally, welding, when it happens, then solidification starts. At that time, only these defects will be formed, right? So, real-time microradiography, real-time ultrasonic testing, these techniques are available. So, definitely, by the product, it gets finished and all cooling process, everything is over, you know exactly which places the defects are there. That is possible. This is part 1. But what I would like to mention is this is not enough. After the 100 products are made, all 100 products can be subjected to entity. And I know that these 5 products are having defects in those zones, take it out. That is not enough. There was a technique, I think very few people are employing that. It's called intelligent processing of materials. That is, when the process is going on, when the defect formation is likely to happen, see, it's not that it happened, likely to happen, some of the key process parameters will be varied. So I'm talking because especially in the context of defense application, they have to be of a very, very high standard, defect rate or whatever you call it. So in situ modification of parameters depending on the shape of the product you are making. It may be oval shape, then it becomes round, the neck formation. These are the prone areas for the defects to get generated. So at these areas, and pre-signal you get in, that this defect is likely to form and process parameters are automatically adjusted. It's called intelligent processing of materials. I think these techniques, especially high-end areas like defense products, we can think of. Thank you.
Sir, actually I was holding myself back not to speak because I am not a A&E specialist. But because Professor Manna said who will ring the bell, I just wanted to quickly share just in a minute or two about a success story or whatever the way forward with respect to the powders. You see, the powders are the common wanted thing for many of the fields, including surface engineering. After I became the head of surface engineering, what I did was like India is importing about 500 to 1,000 tons of thermal spread grade powders from all over the world. So we started populating the local industry. About 6 to 10 industries we have formed a group, and about 15 powders, more important core powders were identified. And then we wrote to BST. BST is kind enough to support us, and we are recruiting about 10-15 people under that category. So what will happen in next 2 to 3 years is we'll be benchmarking all these powders against imported powders, and we will say this powder is 80% okay, this percent is not, this guy is 90% okay, and then the user industry, the powder generating industry also will get a specific market. Okay, I can sell this powder for this application because benchmarking data is available now. Then they can augment with more infrastructure, like Professor Appara is saying, they can go for improved vacuum levels because they are already in the business, they are clear about their ROI. So probably at different institution levels also, those who are having a good number of AI machines also can think of either jointly or independently trying to address our own individual industry partners. Thanks.
Just for information purpose, as a part of our recommendation to the roadmap, for a society we are planning to create into the working groups of complete DRDL, which may be extended to all the academic and industries. They can come and part of it. So we have proposed in the roadmap, sir, maybe just for information to others gathering. So it may be done quickly and so that we invite the people so that we can share the data within the communities. Thanks.
Already said, Professor was also saying, I think in the larger, broader context to keep INA as the center, and we can become them one part of it because we will have anyway something within the organization. And then that can interface to this larger one, so we can kind of provide the core critical mass, which was also good because we already have a larger base.
Yeah, we have a digital platform. Okay. We already have a digital platform. We can able to facilitate that.
Madhusudhan, I wanted to use this opportunity to make an appeal on behalf of INE. Probably all of you were not present when I spoke yesterday in the inaugural function, and I see here is an opportunity, and probably it serves as selfish reason also on behalf of INE. You know, fellows get elected through a very rigorous 3-tier process, and if you look at the number, we are talking about not even 1,000 for a country of our size and economy. And so success rate is very, very small. But then INE now has created another opportunity to embrace much larger number of professionals who are very who are doing extremely good contribution to the profession, and we call that cadre called membership cadre. And any professional with certain amount of experience and engaged in engineering profession, as a scientist, as an engineer, as an entrepreneur, can actually be nominated to be a member of IDE. And we really would like to enlarge our reach to a much larger set of people. And we target 10,000 members. So you can imagine that if I take all DAE, DRDO, ISRO, and then DST, CSIR, all other possible, we are talking about several lakhs of professionals working in very important engineering aspects. If you include the private industry, PSUs and so on, the number is even bigger. So we would like to reach out to you and then make a much larger pool of professionals who actually can contribute. And I think many of you actually have very important experience of on-the-job experience, which many senior people may not be even aware of. So I think that way we possibly, and by the way, I would like to make a statement on behalf of the Academy. A forum, call it a forum or active group or panel or whatever way, we are going to create on additive manufacturing. Because I firmly believe this is a technology area which is still emerging. And in most of the cases, we do catching up job where we actually can be among the leaders. So we will do something with that.
Professor Manna, I just want to make one suggestion. Please bear with me.
It's a very laudable idea that you want to grow open the IIE fellowship to a larger number of people. I heartily second that. However, let me speak very frankly with experience. I've had experience of selection as one of fellows. I would like to say that you have to liberalize the selection process. Now, as long as you put emphasis only on the research contributions, 100 publications or 500 publications weighs more than development of one process in industry, you will not be able to increase membership beyond 80% academicians. If you look at the breakup of the people in the fellowship there, you will find that it's a very big domination of academic people. Many times the chairman of presidents of IATL pointed this out. But then you have to liberalize. Somebody from industry who has got vast years of experience, let's say in a rolling mill, all right? But he has developed, I know several people who have developed new processes, indigenized processes. Well, it doesn't look great if he's not published a paper. But if you put emphasis only on paper publication, then the expansion of fellowship will be there. I mean, you have to evolve different criteria for people from industry. R&D organizations, I agree. Defense, maybe they are limited by the secrecy that what they have their problems. But academic institutions, we publish left and right. What is it? But you have to liberalize the process for industry people. Then you will get many more.
It's really alarmed. Quick response. We are aware. I'll give you exactly the data. At the moment, IME has about 20 to 23% of its fellowship coming from industry, about 48% from academia, about 30% from R&D. If you put R&D and academia together, then the so-called paper publishing community is overwhelmingly large. But IME is aware, and IME for the last few years is making very serious effort to make it 1/3, 1/3, 1/3. It will take time, but it should happen. We are fully aware. But Professor Kudumburao, the cadre that I talked about is not fellowship, it is membership. And it has a different character, different type of entry processes, and is very liberal and open to practicing engineers. So we'll try to reach out when you read those scopes and so on, you'll understand.
Yeah. So we have discussed several issues and challenges what we are facing in additive manufacturing, and many points were we have noted down, and and some of the points I think will come into the recommendations. And I'm very thankful to the panel members and very active, lively presentation, participation of the various participants, and so that we were able to make this particular panel discuss many aspects. So, in fact, Professor Manna and Professor Kutumrao has already summed up the essential part of the panel discussions. So I don't want to go further than that. So once again, I'm thankful to all the panel members and all the participants for their lively discussion on this matter. Thank you.